Welcome to my talk. Today we're going to be talking about enterprise-grade React application and a refactoring journey. So this is my personal journey, which I took in my previous company, and quite funny, in the current company, I have the same exact situation. So that's why I wanted to share this with you and to explain you what I've done, what's the architecture behind it, what's the reasons, and what's the end goal, what are the bonuses and some advices that I want to give to you. So first of all, hello, I'm Bogdan Begović. I'm currently a front-end technical lead at Sysdig and co-founder of Sportico, a small startup based in Belgrade. So on a show of hands, can you tell me how many of you have this situation at work every day, where you have, where you have a train that is an application in production, and you have to run in front of it, fixing bugs every day. You can't stop the train, like it's going to crush you, but you have to do something about it to fix the bugs, and this just continues every day. Why I'm showing you this and what my idea behind this talk is, to show you what was the situation in my previous company, what was the stack, what was the problem. Now, this is the first thing that we're going to talk about, the initial state of the application. Then I'm going to lead you through the vision which I had on how to refactor that huge enterprise application to React and Redux, to show you the new architecture and to give you some advices and bonus points. So let's start with this, the initial state of the application. So the previous company I worked for, it's called Arbor Education Partners. It's a UK-based startup which became a scale-up by the time I was there for years. And the point is that it's a huge enterprise application. When I say huge, think about more than 4,000 web pages, like enormously huge. And you have to figure out a way to create a front end that's scalable enough to support 4,000 pages. Now, yes, of course, many of those pages are generated code, but that makes our job at front end even much harder, because you have to maintain something that is used across 4,000 pages and to be sure that you're not breaking all the use cases. So I'll let that sink in. It was a really messy project. And why I say that is because of this first thing. And again, maybe a show of hands, or maybe you don't have to do that anymore. This is the stack of majority of applications in production. And I know a lot of people, maybe even here, that have this stack, this monolithic stack where you have a backend and frontend together. Everything is cramped into one repository. When you deploy it, you deploy it all at once. When you version it, you version the whole thing. Like, there are many problems with this. As I said, like joint development and versioning, you don't have a power over what's the new version. Is front-end different than back-end? Are they going at the same paces? Are they making the same features on front-end and back-end? This becomes a problem really fast. And this is OK for smaller teams and smaller applications. But when you grow up to an enterprise-grade application where I said more than 4,000 pages, this becomes unacceptable. You also have heavy coupling, where you have dependencies just flying around between backend and front-end components in this API and this front-end component. It just becomes a mess really fast. And the last thing is project structure. When you start growing as a company, more and more developers are going to be joining your team. And now, what happens? This worked when you had 5, even when you had 10 developers. But when you're starting to grow 15, 20, 30, 50, 100 developers, this is not maintainable anymore. Just imagine having one repository, one code base. You have to do merges. You have to figure out the conflicts. You have to figure out all of these things that just make our lives as developers much harder. So as you can see here, the previous state was backend and frontend together. I purposefully made front-end inside of backend because that's majority of application. Let's call it a PHP stack, have the public HTML folder where you just cram all the front-end together because backend developers don't want to know anything about front-end and vice versa, and you know the problems. And ultimately, the build system. This becomes complicated really, really fast Because as you introduce new technologies, you also have to add new build features into it. Like you'll use Node.js and NPM instead of not using anything, or you've used Bower and you want to switch to NPM, then you want to switch to Yarn, and so on and so on. I'm just talking about the front end here. Imagine doing the same thing on back end where you want to introduce Docker and then, I don't know, Kubernetes or whatever you have there. It becomes a mess really fast. So that's one thing. The second thing I want to talk to you about is, in the previous application I worked on, we had this framework called ExtJS. Please, by a show of hands, has anybody heard of it? OK, we have some people. So this is my experience of ExtJS. I hate it, like literally. And why I say this. So the good side of ExtJS is it's one of the few paid JS frameworks. So you expect a lot of it. Like you expect it's tested, you expect support, you expect a lot of nice things, constant development, and so on. But it's not like that. As I said, you expect 24/7 paid support because you're actually paying for it. If you have a bug in the component, you want them to fix it because you're paying for it. They have a ton of finished out-of-the-box components. They work really nice. They're tested and so on. And they've created their entire ecosystem. They have their own proprietary build system, proprietary SensuTouch, which is a mobile JavaScript, mobile kind of hybrid solution. Sencha Architect, which allows you to just drag and drop components to create pages and so on. So in theory, that all sounds nice. But we are here talking about enterprise applications with more than 50 developers developing it. So this becomes unmanageable. Like, if you want to use drag and drop and things like that, that's not for enterprise applications. That's not for these huge code bases. So finally, we come to pros and cons. So as I've told you, they have a lot of these out-of-the-box components. They have complete frameworks, so you don't have to go fish for packages and so on. They have everything inside, and they have great documentation. And that's all the good things I have to tell you about it. As for the bad things, the performances are terrible. So I'm talking about a framework which was built like a few years ago and hasn't been upgraded since. The architecture, I think. The problematic part, one of the biggest problems I have with the ExtJS is that they've used DOM elements for state. Like, now we are using React and Redux and things to save the state. They've basically had the same approach, but used DOM elements to save the state. Now, if you've only worked for a month as a front-end developer, you would know why this is bad. Like, DOM is crazy slow, and you shouldn't use it to save data on the DOM. The next thing is debugging is extremely hard. And why is this? So EXT tried to create this proprietary framework. They've tried to copy Java into JavaScript. Yes, the name does sound the same, but it's definitely not the same, as we know. And the problematic part is they've tried to imitate Java by creating their own class system. Now, this is before ES6, and before we had those pretty class syntax. Yes, we had prototypes and so, but they've tried to create their own class system based on Java. So they would have inheritance, like a classic OP inheritance, not prototypal inheritance. They've created even their own layout engine, rendering engine in JavaScript, bypassing the CSS. So what you get is they've created their own layout schemas and everything, and they do not use CSS. They don't use Flexbox. They don't use grid system. They have their own system where JavaScript is calculating all of that, and that kills the performances. And especially today in this modern age where we have Shadow DOM, we have Flexbox, we have grid system, we have all of these goodies that can help us, they've decided to create something of their own. And that was maybe good 5, 6, 10 years ago. But currently, it's really outdated. So also, another problem I had with it, build tool, their proprietary build tool. The uglification part was really bad. You couldn't rely on NPM packages because they had their own. They've used YUI, which is a really old tool created in Mozilla like 15 years ago to do that. And the same thing didn't have source maps. So you couldn't, like, if error happens on production, you couldn't actually pinpoint where it was because you don't have support for source maps. And of course, as I said, paid support isn't really helpful because by the time you reach them and they actually fix the bugs, it's 2 or 3 months, which, I mean, you could have done in a few days, but you didn't want to mess with their code. And community is practically non-existent. You don't have tutorials. You don't have anybody to ask about it. So as I said, a lot of these problems. So we've decided to switch and move to React and Redux, a more modern stack, which will help us grow and help us scale this front end to, let's say, 10,000 pages more, if we need to. So this was the initial architecture of the front end. You have your routing, data store, networking, error handling, your core business logic or domain, web pages, and UI components. This is really standard, and I'm deliberately keeping it simple because this can be applied to any application. Switch ExtJS to Ember, to jQuery, whatever you want, this will apply to that. Because I'm talking here about the core architectural principles that I needed to change in order to implement a framework. So this is not about, per se, an implementation details, because that comes easy when you solve the actual architecture. So this was the initial architecture. Now, what was my vision? I've shown you the monolithic repository. I wanted to move away from that. I wanted to move away from ExtJS and introduce a new framework that's going to help us with performance. But I also wanted to lock us out of a proprietary framework that in the future we don't have to depend on that. And this part really goes well with what the keynote speaker was talking about. So you don't want to have this architecture where you're dependent on some framework. You want to have it in vanilla.js. And I'll explain to you why later, but the core point is you don't want to lock yourself to a specific framework. In a few years' time, that framework become obsolete, or they found a critical bug which they can't fix, or whatever the reason in the case is, you don't want to lock yourself to that. So starting with the vision, as I said, I want to first separate the front end from the back end. I want to inject React and Redux into the application somehow, then rewrite the application core, and at the end, create component rulebook. Now, if you follow all of these, as I said, it doesn't matter if it's ExtJS or jQuery or Ember, you can see the actual architecture and the actual idea what I'm trying to present to you here. So let's start with the new architecture. So separating front end from back end. Now, this is a repeated slide because I really want you guys to remember this. We've talked about all of the problems of this architecture. We really want to do this. And it doesn't like this is not rocket science. We just want to split them. But this is a really major point that you have to do this. Because I'm not joking, I've done this professionally in companies, as a contractor, as a contributor to open source projects. Everybody makes this mistake first. Most back-end developers don't care about JavaScript or front-end or whatever. So they just use what they need to survive, to just push the application. And this part comes exactly there. Because they've started their application, added front-end in public HTML, forgot about it, don't care about it. Now, this part becomes really serious. I know that it's just 4 squares and it doesn't mean much, but in the ideology, it really means much, because if you think about it, separating backend and frontend, separating their build processes, what that allows you to do is that allows you to grow as a company. You're going to hire 10 more backend and 10 more front-end engineers. They're going to be working separately. Yes, they'll have meetings, they'll communicate, but they're not going to clash on the same repository, doing commits on the same branches, and going through hell to merge all of that. They have these separate repositories that they can work on. They also have separate build systems they can run manually and version differently, because let's say backend is going much faster than frontend, so they're on the version 1.3 and we are on the version 0.4. They're going much faster. In the previous monolithic repository, you couldn't do that. Now you can. The next thing is injecting React and Redux into the application. But before that, let's first talk about React. Like, I know you've heard a lot. You probably are using, majority here maybe using React or Vue or Angular, but the point of React is, and why I've chosen it to this specific project, is, first of all, extreme rendering performances because of virtual shadow DOM. It's totally opposite of what I had now with the ExtJS, and the best part here is it allows for atomic design and component-driven design and development, which we're going to be touching later on. But why this is a big thing is because you remember I told you that we had more than 4,000 pages which were generated from components. I needed a framework which will allow me to create really good components where I can stack them together and really reuse a lot of these stuff. And React gave me that. Exactly that, with really good performances. Again, separation of concerns was a really important thing because I don't want components that are depending on one another. Because I use them across 4,000 pages, I can't be sure if, let's say, in a year from now, I want to refactor some component. I don't want to go back and just look for all the use cases of that component to figure out all the dependencies. So that's why I needed this separation of concerns and higher order components to achieve that reusability. Because I would, let's say I would have some stupid utility function that I need on some button, but on the other buttons I don't. I would use it just where I need it. And it's in higher order components, so it's separated from the core button code, and I just use it where I need it. So that means that when I go and refactor that button, I don't have to go back and search because I know that that particular function goes into the higher order component. I've reused it a lot of times, and I'm not afraid to actually change it. The next thing is Redux. Now again, you've probably heard a lot about Redux, but the major points here are Redux is a single source of truth for my application. So all the data goes into Redux and is read from Redux. It's framework and library agnostic, and I'm going to show you why that really matters in this scenario where you have two applications, or better say, two frameworks in one application. Because I want to do an iterative development. I don't want to just, like, I don't have the time and don't have the money to go and just stop the development, take 2 or 3 years to just rewrite the application for 4,000 pages. I don't have the money and time to do that. So what I can do is do an iterative approach where I'm going to include both frameworks. And Redux is going to allow me to have both frameworks running together. Now, I know this might be a scary approach, not conventional approach, but it's the best thing to do in iterative development, because what I can do is, in every cycle, I can take one component from the old part, move it to the new part. It's going to use the same services. It's going to use the same data because of Redux, because of that layer. And I can be safe that I'm moving them one by one in a proper fashion. And the last thing is great place for data sharing. And why this is important, because if Redux is sitting below like these two applications, these two spaces, it's the same for both of them. I can be sure that the same data is shared between those two applications. And this is really important because if I break a UI on my web page for my clients, it's not that big of a deal. But if I screw with their data, that's going to kill me. And that's why Redux needs to be like the single source of truth and needs to say the same for both spaces. Now, you remember this. This was the initial architecture. In the new space, I've added React, so it lives independently of this, the old application. I'm not cramming it in. I'm just adding it to a web page. It lives separately. It doesn't clash with the old application. And I'm going to move the next thing, the data store, into Redux. So there will be no data store in the old application. All the data from networking will go to Redux store. Now, how I'm going to achieve that is as I said, Redux is agnostic, doesn't care about frameworks. Yeah, it's used a lot with React, but it doesn't have to be. And that's the thing. You can just use these literally 4 stupid methods to dispatch the calls, to get the state, and that's how you would use it from the old application. Just whatever comes from networking, you just push it down, that's it. And the big thing here is, so all the old network calls need to incorporate this, even in the price of like duplicating your data. That's totally fine. Like if it duplicates it, if you can't remove the old data store completely, that's fine. You will have it in 2 places for now. Then continue just refactoring it. Now, I was talking a bit about rewriting the application core. Now, this is a big part, and what does that actually mean? So in this new diagram, I want to move networking, error handling, and core business, better say domain logic. I want to move it out. I don't want it to be tied to any application per se, any project. I want that to live as a separate package, and I'm going to explain to you why. One of the new, let's say, requirements I have with my current company, where I'm doing exactly the same thing with Ember.js, not ExtJS, but literally the same thing, is it was created for one application, but now we're branching to a second application at Sysdig. First one is monitor, the second one is secure. Basically the same projects. They have the same core, the same UI, the same everything, but the purposes are different. Here, you have monitoring of Kubernetes and Docker and all these containers where the data is fed, and you show it there. But on the second project in secure, you need to scan the images for vulnerabilities and things like that. So logic may be a bit different, but they're reusing a lot of stuff, like users and getting the data for users, and sharing that data of what you monitor, then feed it to secure to scan it, and so on and so on. So why I'm telling you this is because of that reason, this is a good idea, to move the core, the domain logic, into a package and write it in vanilla.js. And why I say vanilla.js? Because you don't want your business logic to be tied to a framework. That was a lesson I learned from a previous company where all of the business logic was tied to ExtJS. And that is a problematic part because now your core business logic is relying on a framework that you're trying to move out from. And so that you don't get to be like in that same situation again in the future when you're moving from React to something else, you want that to be in your vanilla.js. Sorry. And again, that goes the same for networking and error handling because that's a similar thing. Now, here we have separated the core from the rest of the app. We've rewritten the rewritten the core in vanilla.js. What we want to do is create a service layer and create a global interface layer. And I'm going to explain to you why that is really important, and then have these optional improvements, which are highly recommended. Now, creating a service layer. This is something, again, a really important part, because services are, they live in your core. And they're like, in this stupid example, get the user data and set the user data. You would have these services functions, and the thing is that you now want both the old and the new application to use the same services, because the new services save the data into Redux. You don't have to duplicate anything. So you want to use the same services. Then you maintain only one services and so on, so it has multiple benefits. But the point here becomes, so yes, now you create this layer of services. You will do that eventually, I mean. But the thing is, how do you export it for the old application to use it? And I've came up with, I'm not sure if this is the best term, but the global interface layer. Why I called it like that? Because I use a global constant, this sysdig.interfaces, and put the services that I've exported, and I actually just attached a reference to a global scope, so that the old application can just use that service from a global scope. Now, yes, I know what you might be saying, that the global scope might become dirty and so on, but I'm hiding it in the window.sysdig.interfaces, so I know where they are living. I can kill it if I want to, and it's not going to pollute anything else, any other library or whatever, because I've deliberately put it there. And the major point of this is to allow my old application to contact the new services, but not to inject services, the new services, into the old application. And that's important because I don't want to work on all application anymore. I just want to work on the new part. So that's the point of this global interface layer. Now, moving forward with create component rulebook. Why is this important especially for enterprise applications? When you have enterprise applications, you want to have a consistent UI and UX. And that's a must. That doesn't need to be pretty, doesn't need to have like crazy animations and things, but it has to be consistent. And that's what your users are expecting of you. Now, to be consistent, and going with what I've told you that those 4,000 pages were generated from the components that we have, you have to create these components in a really consistent way to have a unified design language so that you can propagate that UX to your users. And how are you going to do that? So you have to work with your design team, and really, like you, the developers, have to sit down with the designers and talk with them to explain what are the problems from engineering side, and also to understand what are the problems from the design side. Try to find a common place, because if you don't do that, there are two possibilities which I both seen them in like real life. One is you're just going to get the designs from the design team, and it's going to kill your engineering team. You're going to hack a lot. You're going to try to find crazy solutions to something that the design just envisioned, which is not how you do, let's say, HTML or CSS. That's why you have to talk with them. The other way around is your engineering team is too strict, doesn't allow for anything, and you end up in the 90s with the table layout and so on. Like, we don't want to do that. So the next part comes naturally, and that is implementing these UI components. So you have to talk with them, get the design, like agree on a specific design, and then, of course, go and implement it. But so what I can give as advice here is the atomic design. I'm not sure if you've seen it, used it. It's mostly a design topic. But this is a perfect thing for React. And it probably goes well with Vue.js as well. But the point here is, what is atomic design? So you have these 8 atoms, which combined gives molecules, combined gives organisms, combined gives templates. And at the end, when you put the data into the templates, you get the page. Now, this, again, doesn't sound radical. But just try to think of it like this. These atoms are your components in React. A highly reusable components, like base components. So you would have an icon, you would have a button, you would have an image. Then what molecules are is you get those base components, and then you go here and create a header. A header is an icon and the text, and another icon. And this icon lives in a button. So it's icon in a button, text, icon in a button. The same goes with all of this. And then moving forward, if we take this example, we have an image header, which has a smaller icon inside and a text. Then you have an image, and then the same thing for the toolbar. 2 icon in a button, better say 3. And then when you combine those 3, you would get a higher order component, and it would be this one. Like just combined of those components. As I said, nothing revolutionary, but majority of the people I worked with tend to miss this point. They're afraid to break down these components, but that's the only way how you're going to achieve the reusability. So moving on from organisms, you create templates, which becomes your page without the data. You feed the data inside, and you get the complete page. That's the point and the idea of atomic design. And moving on, it's the Storybook tool. You've probably heard of it. Again, not revolutionary, but what we figured out with Storybook is this is really interesting part. You don't want to just document your components in Storybook, not just test them there. You want to document everything in Storybook. Why? Because, again, you want a single source of truth for the design. So when a product manager comes to you, tries to like go crazy with some page, you just refer them to Storybook and say, pick a component. It's consistent, It's much easier for the developers because they're using components they already have, and you're preventing your product managers of like going crazy with the design. And with that, you also document your colors, typography, whatever other design rules you have, which are going to help you a lot because everything is in the same place. So let's go back to our architecture here. So we've used the Redux store to have the shared data and single source of truth for these both application spaces. We've moved out the application core to Vanilla.js, moving all of our networking and error handling and domain logic there. Also, we've created our reusable React components and added them into this application. What stays here is the routing, because this one, and this is, again, from experience, you want to figure out this one last. And it's really hard to do with two applications. You don't have to worry about it, because by the time you've refactored all components from the old app to the new app, this will just like disappear. And it's not going to be a problem when you do all of that. What stays here are web pages and UI components. So for a particular applications, you would always have some specific UI components that are special to that project. And all of the web pages are going to be using those React components that are reusable and these special components to create the web pages. Now, what are the benefits of the new architecture? So we have improved maintenance and code quality assurance. You now know what you're building, you've separated it, it's much easier to maintain. Those bonus points I've mentioned earlier might be that you've added Jest with Enzyme unit tests. You've done a TDD with this, which is like, in my opinion, a must-do with the refactorings like that. When you're moving logic from one application to another, first write test, then move the application, it's going to save your life. So you have improved maintenance and code quality assurance. You have reusability. You have reusable high-level architecture components. And I'm going to show you what I mean by this. And I literally mean high-level architecture components, not just React buttons and icons. And that's all reusable. You have easier cross-team and platform development. It's much easier for everybody to collaborate, to work with each other. And you have you are React Native ready. Now, this is a really interesting part. I don't know if you guys have tried React Native and have played with it. But I've written code that is in production in React Native. And what I can give you as an example is that this whole thing that you've seen here, especially this application core, is reusable in React Native. What that means is that when you do architecture like this, you have more than half of your application done in React Native. Now you just need to write the components and figure out the views. That's it. You have the domain logic, you have the networking layer, you have the data layer, you have the services, you have everything. Just literally use that package in the new React Native application, and you have a React Native project. And it's one of the biggest highlights of this presentation and this architecture is that you get it two for the price of one. So what I was talking about is those high-level architecture reusability is actually this. Let's say that I gave you an example earlier. This is monitored, this is secure. There's going to be 2 new projects coming in, but all of them are going to use the same core business and domain logic. And that's why this is so powerful, because you can literally reuse all of that right part of the screen for projects. You have completed components. They're all in the same exact design. And again, we're talking about enterprise applications here, so it's expected that everything looks the same. You reuse the core of your applications, and it's much easier to write new projects. So we came to final advices and bonus points. Now, I was thinking, should I start with this? But I was worried that I should probably give you some context. But these were the struggles that I've struggled with. And these are maybe some of the most important parts of this presentation. Yes, I've given you the new architecture. Yes, I've shown you the technical part. But trust me, these are much harder than just sitting down and writing your code. Because first, to even start doing that, you have to get a buy-in. You have to make your CTO believe you. You have to create proof of concept and show to person in power that you can actually do this. And you have to get this buy-in first so that you can have a person trusting and believing you to push you forward. The next thing is you have to create technical strategy. This one is probably the most overlooked part. With whoever I talked with, everybody forgot to do this, creating a technical strategy. This is not a roadmap. This is not a product roadmap that you have to create this feature or this feature. This is a technical strategy. What that means is I have to refactor to Redux. Your product doesn't care about Redux. They don't even know what that is. So you have to create a strategy and stick to it. Align it with business goals, because you're going to always find opportunities to refactor this component or include this, refactor this service. And going along with the product roadmap, you're going to include your things from the technical strategy and just clear out this technical debt that you're buried in. The next thing is, and this is a must if you want this to work, this new architecture, and that is old code, old architecture, maintenance only. You don't want to write new code there. If you do that, I'm guaranteeing you you're going to forget about it. And when you go to the new application, you're going to forget that you have some code that you've written in the meantime. You're not going to refactor it to the new app, and then you're going to start wondering what happened. And it actually happened to me, so this is really from experience. Old code, maintenance only. New code, new features, everything else. This part is what I'm struggling currently with, and I don't have a solution for this, to be honest. Don't create your own framework. What I've seen in the past is people have been using one framework for years. And going to React and Redux, they have to change their mentality to switch to this new paradigm. And they're making, this is way hard for them. I'm not sure why. But the problematic part here is they're trying to copy the same architecture from the old application to the new one. And you're actually escaping from this architecture, want to move to the new one, but you have these things of the past that are haunting you constantly. So you have to put an end to this. Like currently, in Sysdig, I have a problem with, so in the past we've used Ember data. This was and still is a really good project. It's maintained by 30 or more people. It's been in development for a few years. They've sorted the bugs and everything. And now we've gone to React and Redux. But one of our technical leads decided that he's going to rewrite the Ember data to React. Now, this is a one person doing that in a week versus 30 or something developers working on it for years fixing bugs. This is not going to work. And this strategy and this architecture is not the same for these two, Ember and React. So please don't do this. The next thing is be transparent and document everything. You want to avoid the bus factor. Do you know what a bus factor is? No? So what happens if a developer, I mean, this is morbid, but what happens if a developer gets hit by a bus? And he was the only one who knows how some component works. This is a bus factor. And you want to avoid this. You have to transfer your knowledge, document everything, and be transparent about it. And the last thing is generate some hype to keep the momentum. You want to celebrate all the small victories. And what I've done in the past was I've used to track the performance of our website. So when I joined my previous company, JavaScript bundle, which was served to the client, was around 15 megabytes. Uncompressed, uglified, and so on. It took around 60 to 70 seconds just to download first that 15 megabytes in a regular average connection, then again around a minute to go through and evaluate that code, and then like imagine it was like around 5 minutes for that first acceptable input from the user, which was too high. And what I've done through the years was measure that once a month and see where we are. And I would celebrate all of those victories with my teammates. I've also done that every time we move component from old to new architecture, we would celebrate it. This doesn't have to be like a turkey dinner celebration. We can just go for beers or, I don't know, share a chocolate or whatever, but share it. Create a hype, create a momentum in your team so that they would want to do that. And yeah, if you know how, tell me how to do that. And yeah, the last slide is, these are bonus points. This is something that helped me. It's creating your front-end dashboard, which goes with transparency. You want to include there a storybook link, just test reports to see how it's going. You want to do the test coverage there and also all of your JS documentation to have, again, single source of truth from one point that you can go refer somebody to documentation for onboarding purposes and so on. For setting up coding guidelines, and this is really important, using ESLint to prevent like linting your code, preventing bugs. Do prettier if you want to have the standardized layout of your files. Using pre-commit hooks with Husky to allow linting and unit testing before the code even reaches the repository. And the last thing is, unfortunately, I don't have time to show you this, but this is really awesome. Using TestCafe and Backstop.js for functional and CSS regression testing, which is a whole separate topic, but is really important. You can use it to make sure that your code runs and works as expected. So thank you all, and if you have any questions, we can go through them now or later in the lobby. That's it from me.